Hello students, today we'll see heaps and heap sorts, heap sort algorithms. A heap, what is a heap? A heap is a complete binary tree or almost complete binary tree satisfying the two conditions. What are those conditions? First condition says that all its levels are full except possibly the last level. If the last level is not full, all the nodes should be filled from left to right. Second condition is the key at each node is greater than or equal to the keys of its children. So what it says here, a heap, it is a complete binary tree or it is almost complete binary tree, and it should satisfy the following two conditions. What are those two conditions? All its levels except the last level, it should be full. Last level, if it is full also, it should be filled from left to right. And second condition says that the key elements, the key at each node is greater than or equal to the keys of its children. See here, you can check here. This is a, you can see here. All its levels should be full. All its levels are full. And the second condition is the key at each node is greater than or equal to its children. Here first, if the last level is not full, all the levels should be filled from left to right. You can check here. Left and right is left out. So we call it as a heap. And also it should, all its parental node value should be greater than the child node values. Its parental value is 45, child node is this one. Here it is 60, here it is 70. And when it comes here, it is 45 and 60, it is greater than. But when we come here, the first condition is, check here, 45, 60, it is greater. Here also 25, it is greater 15. But according to the condition that it should be full from left to right, here the left child is not there. So we call that it's not a heap. So this is an example of heap. This is not a example. This is not a heap. What are the properties? So we have various properties of a heap. What are the various properties of a heap? The first property says that the heap must be a complete binary tree or almost complete binary tree. Its height is always a log n to the base 2. The root of the tree always contains the highest element. We have seen just now. The root of the tree always contains the highest element. Next, each subtree, when we are constructing, each subtree must be a heap. That is, children of a node must be less than the parent node. In a heap, all the nodes, how we are going to number the level, how we are going to number the nodes, all the nodes are numbered level by level from left to right. The next is, given any node I, position of left child is given by 2i plus 1 and the position of the right child is given by 2i plus 2. Given any node I, the parent position is given by I minus 1 by 2. As we have seen there previously, it is according to that. So we'll see the example how to construct a heap. We will take this example. Create a heap for the elements. The elements given are 5, 35, 25, 45, 20, 55, 25, 45, 50, 10, 30 and 15 using the bottom up approach. First, to make it as easy convenient, first we'll write those elements in the form of an array. What all the values are given, we have in the form of an array 5, 35, 25, 45, 20, 55, 25, 45, 50, 10, 30, 15. For this, we'll try to construct the tree. How do we construct the tree here? First, see here, 0, take here. First, it will, first as according to the conditions of a heap, first the left child will be added, then right child. So first element you can check here. First element we are written it as 5, it is a root. Then next 35 left side, 25 right side. Again we'll start with the left and right. So again 45 comes to the left of this 35 and 20 comes to the right of this 35. Again the next element is 55. Here left and right both are filled. We can't go to the next level. What we have to do? In this level only we have one more right child. For that we'll try to add. So 55 is added as left child. Again when we go here 25 is added as a right child. Again go here. We have the next element 45. 45 here the left of this one is 45. Again next element is 50. Right of this is 50. Again next 10 is there. Again we'll go to the next here. We have a 20 here. Left of that is 10. Right of this is 30. Then next last 15 is left out. So we'll add here. We can't randomly add here or right side. Always it is left, right, and two childs, maximum two childs per node, as it is a binary tree. So here we are going to have left child. We are going to add it as 15. Then we have to check. Always according to our heap condition, parental node value should be greater than its child node value. So we should go on checking. Here we don't have any left or right child. We'll leave it off. We'll go to the next one. Next, see, as the numbering from left to right child, 0, 1, 2, 3, 4, 5 second levels of numbering. 5, 6, 7, 8, 9, 10. Here I don't have anything, so we will not think of this one. We'll go to this part. When we go here, we can check there is a left child is there. What is the value here at the left child? 15. 55 is the parental node value. Is the condition satisfied? 55 is greater than its child node 15, and as this subtree satisfies the heap condition and no changes are required. Parental node value greater than the child node value. Yes, parental node value 55 is greater than child node value. So for this subtree, no need to make any changes. We'll go to the next part. What is the next? Again, we have to check this part. Here we have to check in the next step. We have to check the next level. This is done and no exchange was required. Then we'll go to the next part. 20, 10, 30. Here 20, 10, 30 was there. Check here. 20, 10, 30 was there. What is the condition? Parental node value should be greater than the child node value. What is the child node values here? 10 and 30. 30 is greater than the 20. What we need to do? We need to exchange 20 and 30 so that the parental value, the node value is greater than the child node values. So here, after comparing, we'll exchange it. Why we are exchanging here? Because the parental node value was less than the child node value. So as it was not creating clearly it was not a subtree, is not a heap. So what we do, we need to make a changes. Once we make a changes, you can see here, that is swap. Changes means swap. Bring 20 here, 20 here, 30 here. We have swapped, and then when we see this one, this subtree is a heap. Parental node value is greater than the child node. So leaf node or child node, whatever we'll call. So here child node, leaf node values. Then next we'll go here. We'll go to the next. Consider the last leaf node, that is 45 and 45, 45, 50. Now again we whether is it a heap? Is it a heap? No. Why it's not a heap? Because here again the 50 is greater than 45. So what we need to do? Again we need to swap 50 and 45. You can see there is that 45 is equal to the left child and less than the right child 50. So clearly we know that it's not a heap. What we need to do? We need to swap now. 45 and 50 need to be swapped. Once we swap the 45 and 50, now we'll see that subtree. Check it out. Is this subtree a heap? Yes. The parental node value is greater than the leaf node. Leaf node is 45 and 45. So it is less than the parental node value. We should go to the next level. Next level, right and left. So we go to the next level. We'll check this part. Next level is go here and check. This part we need to check. You see, if you check here again in this part, so according to the definition of a heap, parental node value should be greater than the child node value. But here if you check, 25 is less than the 55. So what we need to do? We need to swap 25 and 55. If you swap, now swap the 25 and 55. So here you can check here. We have swapped 25 and 55. Now check this level. Whether is it a heap? In all the places, you can check here whether the parental node value is greater than the child node value. Child, yes, it's true. Because here 55 is greater than 25 and 25. Again 25 is greater than 50. So go to the next part of the another right part of the tree. When we go to the right part of the tree, again you check here. Here we have parental node is 35, whereas child node value is 50. Here again we have 45, 45, 30, 10, 10. So here the parental node value is less than the child node. So what we need to do? Again we need to exchange or swap. That is, bring the 35 to level 3 and 50 to level 1. If we exchange now, bring 35 to 50, we have exchanged. This has become a heap, but we have to completely check with this one. So after swapping 35 and 50, again check whether it is forming a heap or not. No, it is not forming a heap, because again if you check here 45 and 45, here it is 35. This is greater than this is less than our child node values. So what we need to do, we need to exchange with the child node value. But again, if you see here, there is a tie. Here is also 45, here it is also 45. When the tie occurs, usually we are going to change with the left child value. So left child is 45. So what we'll do, we'll exchange swap 35 and 45. When we swap these 45 and 35, we'll get a heap. Swap it and check. So here, if after swapping, we'll get it like this. Check here. Consider the leaf. So here this we have done. This is done. These two are swapped. Brought 35 is brought to the down level left child value. So now you check here. Is it a heap? Yes, 50. 50 is greater than 45 and 30. Again, when we go to 45, 35 is less than 45 and 45 is equal to 45. When we come here, again 10 is less than 30, 20 is less than 30. This is less than 50. Here also it is heap. Now this part, this level is also a heap now. Next we have to go consider the last node, that is 5. Is it a heap? If we consider totally, is it a heap? No, it's not a heap, because 5 is less than the 50 or 55. Now you check here 50 and 45. With which we are going to swap? We are going to swap with the right child, because that is greater than our left child. Swap it, swap 5 and 55. Always you remember that it has to be swapped with the largest of two children. So among these two, which is the largest children? 55 is the largest. So swap 5 and 55. 55 comes to root node and 5 comes here. Again you check. 5 is here, means you check here in the next step. 5 has come here. When 5 comes here, again we need to check whether it is a heap. No, it's not a heap. Why it's not a heap? Because 5 is less than 25. So what we have to do? Again, we need to swap. Here also there is a tie is there, 25 and 25. So with which child we have to exchange? If there is a tie in both left and right child, it is better to swap with the left child. So if you see here, we have swapped here. 25 has brought to the upper level, whereas 5 has come to the 5 has come to lower level. Now again you check here whether whether it is a heap. No, it's not a heap. Again, the parental node value is greater than the child node value. So what we have to do? We have to swap again 5 and 15. If 5 and 15 are swapped, we can see a tree. We check the we after swapping we'll get a following this as a tree. Once we check this one, check whether 525 yes, 515 yes, 1525 yes, it's true, it's heap. 2010 heap yes, 4535 heap yes. Again check this one, 30 and 45 yes, less than 50. Again check 50 and 25, is it less than 55? Yes, sir. So this is the heap what we are obtained for the given problem. Next we will see, this is how we are going to construct the heap. So create a heap they have mentioned. The given example is create a heap using our bottom up approach. This is how we are going to, what we are going to do. We are going to start with the first one. Then we will go on level by level. We will go on checking whether the conditions are satisfied. If the conditions are satisfied, there is no exchange is required. But if the condition is not satisfied, then we should swap the elements between the leaf node and child node. This is the main thing in our heap. I think it's clear. Hoping that it is clear. I'll go to the next part. Next is heap sort. How do we perform a heap sort? What is a heap sort? Heap sort is a sorting technique used to arrange the numbers in ascending or descending order. What we are going to do, it is a sorting technique where we are going to arrange the numbers either in an ascending order or a descending order. This sorting technique uses creating a maximum heap so that root is highest element and its children are less than the root node. Here the root is going to have the highest element, whereas its children are less than the root. The advantage of this technique is sorting technique can be easily implemented using arrays. Here we have two stages here. First stage is heap construction, that is construct a heap for a given array. Second stage is maximum deletion. Apply the root deletion operation. What we are going to do? We are going to apply the root deletion operation n minus number minus 1 times to the remaining heap. Sorry. So our Heapsort algorithm works in two stages. First stage is heap construction. How do we construct? For a given array, we are going to construct a heap. Maximum deletion, apply, we are going to do maximum second stage. Now we are going to apply the root deletion operation n minus 1 times to the remaining of the heap. This is how we are going to perform the heap sort, how we are going to sort the heap. See, this is a given example. Sort the below given list by heap sort. So this is the given list 7, 4, 3, 1, 2. Just try to construct a heap for this 7, 4, 3, 1, 2. Is it a heap? Check it out. 1, 2 is less than the parental node. 3 does not have any child node. It's a binary, it's almost complete binary tree. 4, 3 are less than 7. It's almost complete binary tree. Again, the second condition is parental node value should be greater than the child node. That is also done. So first heap construction is done. Next step is maximum deletion. So what we have to do? We have to delete maximum element first, then maximum, like this we need to delete the element. So, but if you check here, 7 is maximum as and 2 is least. So we can't directly delete the root. What we need to do is, for that purpose, we have to swap this with the last element. So 2 is here, 7 is here. What we'll do? We'll swap 7 and 2. 7 comes here, 2 goes in this place. Then what we'll do? We'll delete the 7. 7 will be deleted. Bring this one, swap it, bring the 7 to this position, then remove this part. So 7 is been deleted, maximum deletion is done. Then again, go to the next step. Here, it has been deleted. Now we have this one. Is it a heap? It's not a heap. Why? Because if you check here, according to the heap condition, 4 and 3 are greater than 2. What we have to do if that is there to construct the heap, we need to swap with the greatest element of the child node. So here 4 is greater than, 4 is among 4 and 3, 4 is greater. What we'll do? We'll swap 4 and 2. 4 and 2 is swapped. Now we'll get, once we swap this one, we'll get this as a heap. Once that is done, what we have to do? Apply the maximum deletion. To apply the maximum deletion, again we need to swap 1 and 4, because remember that root node cannot be deleted. Child node one by one we have to delete. In the first step 1, we have deleted 7. In the step 2, what happens? The 4 will come here and 1 goes here. Once the 4 comes here, that will be deleted. So we'll get like this. 1 is here, 4 is here. Delete this one. 4 has been deleted. Then we are left out with this one. Is it a heap? No, it's not a heap. Why it's not a heap? Again, the maximum should be 1 is less than 2 and 3. So we have to exchange with the maximum element. The maximum is 3. Swap these two. Once we swap these two, again exchange it, the 3 will be eliminated. 3 will be deleted. Maximum deletion, 3 will be deleted. Once 3 comes here. After deleting the 3, what is left out with us? After deleting the 3, we are left out with 1 and 2. Again, here it is 1 and 2 is there. Again, 2 is greater than 1. Bring 2 here, 1 goes here. So 2 will be deleted, then 1 will be deleted. We can see that 1, 2, 3, 4, 7. This is how we are going to construct how we are going to apply the heap sort. This is how we are going to perform the operation. Check here. Next. If you see one more example here, construct sort the below elements, below array by heap sort. First construct the heap. Once you construct, you will get it as, so 2, 9, 7. So 2 root, first element root, then left child, then right child. Again for this left child, right child, for this left child. So we'll get like this as an pre-construct, but it's not an heap. Why it's not an heap? Because maximum element should be on the root node. So here it's not an heap. What we have to do? We have to go on exchanging the things. Can I exchange 2 with 1? What we need to do here, according to our heap construction, we are going to exchange 2. First we'll go on doing from left onwards, left child onwards. Check here, 7 and 8. No, it's not a heap. Bring 8 here, 7 here. Again 5 and 6 less than 9. Okay, no problem. So here 8 has come here. 9 and 8, among these two, which is greater? 9 is greater. Bring 9 here. 2 comes to this position. Then again next check here. Is it a heap? Is it a heap? No, it's not a heap. Again here the 2 is less than 6 and 5. Among these two, 6 is greater. Swap with this 6. 6 will come to this position and 2 will be in this position. We'll get it as 9, 6, 8, 2, 5, 7. Now I think it's heap. You can see here 8 greater than 7, 6 greater than 2 and 5, 9 greater than 6 and 8. Now it's a heap. After constructing a heap is next step is maximum deletion. To do the maximum deletion, what we are going to do here? Exchange this 9 and 7. So 9 comes here, 7 goes to this position. So which will be deleted? 9 will be deleted. You can check here. So 9 and 7, heap construction is done. Whatever the steps we are done, then comes the maximum deletion. In the maximum heap construction, whatever we got there, that has been written here. Stage 2 is maximum deletion. In maximum deletion, the root node is going to have the highest value. So exchange this one. Once you exchange this one, we'll get like this. Next you can check here. This is exchange and 7 goes to this place and 9 will come here. That will be deleted. You can see here 7, 6, 8, 2, 5. Maximum is deleted. Again next step. Again 7 is not an heap. Construct a heap. Bring 8 to this place and 9 to this location. So we'll get it as 8, 6, 7, 2, 5. But again we have to delete the maximum. So again what we have to do? We have to swap. We have to we can't directly exchange here. What we have to do? Again we have to go to this level. 5 is there. 5 and sorry. If you go here, 8 is here, 7 is here. 5 and 8 will be exchanged. After exchanging, 8 will be deleted. You can check here. After exchanging, 8 is deleted. Now we are left out in here is 5, 6, 7, 2. 5, 6, 7, 2 is left out. Then go to the next step. Now we have 5 here, 5, 6, 7, 2. Is it a heap? No, it's not a heap. What we have to do? Again, we have to exchange with the maximum one. 7 goes here, 5 comes here, 7 goes here, 5 comes here. Again, we have to exchange 7 into 2 goes to this place, 7 comes here, delete it. So 7 is deleted. 7, 8, 9, 7 is deleted. Now we are left out with 2, 6 and 5. 2, 6, 5. So again, it's not a heap. Construct and make a heap because in a heap the parental node value should be greater than the child node value. So 6 goes to this position and 2 comes here. Now after that one we have to exchange 2 with 5. So, 2 with 6. After exchanging this one, 2 and 6, 6 comes to this position and 2 will be here. Then what we have to do? We have to delete a 6 here. In this position we have deleted 6 here. In the next step, 5 and 2 is left out. Again exchange these two. 5 and 2 is left out. 5 will be deleted. Then comes 2 will be deleted. You can see here. They are arranged in ascending order 2, 5, 6, 7, 8, 9. The step procedures, whatever we are adopted there, whichever is deleted, first 9 was deleted, 8 was deleted. The same, whatever the steps we got here. 9, 6, 8, 2, 5, 7. 9, 6, 8, 2, 5, 7. In the next step, 7, 6, 8, 2, 5, 9. 7, 6, 8, 2, 5, 9. 9 is deleted. Now we are left out with 8, 6, 7, 2, 5. Check here 8, 6, 7, 2, 5. 9 is deleted. Next up 5, 6, 7, 2, 8 is deleted. 5, 6, 7, 2, 8 is deleted. 5, 6, 7, 2, 8 is deleted. Now we have in the next step after rearranging, bringing this one to the parental position, we get 7, 6, 5, 2. So exchange it. 7 is deleted. We are left out with 2, 6 and 2, 6, 5. Next step 6, 2, 5. Next 6 has to be deleted. We are left out with 5 and 2. Exchange this. Left out with 5 and 2. 5, 2. Again exchange. 5 will be deleted. 2 is left out. Last 2 will be deleted. You can check here how we have got. Then bottom 5, 2, 5, 6, 7, 2, 5, 6, 7, 8, 9. The elements are arranged in an ascending order. This is how we are going to construct the heaps, how we are going to perform the heap sort. Thank you.